Okay, this is video 2 from our lecture video series from Monday, March 20th, where we are going to go over balancing chemical reactions. So let's begin with a brief reminder. Recall, chemical reactions obey the law of conservation of matter, which is another way of expressing the law of conservation of mass. So I have given us this chemical reaction here. And what we know about this based on the law of conservation of matter or the law of conservation of mass is we need to have the same number of atoms of each element on both sides of a reaction arrow. Meaning if I start with some number of carbon, hydrogen, and oxygen atoms, I should wind up with the same number of carbon, hydrogen, and oxygen atoms because atoms are neither created nor destroyed in a chemical reaction, they are simply rearranged. So let's ask ourselves, does the given chemical reaction above obey the law of conservation of matter, LOCOM? So that means we've got to do some counting. I'm going to symbolically write my reaction arrow so that I can have a tally of my reactants here. My starting materials, and then a tally of my products on the right. So starting with carbon, I need to now read my subscripts to figure out how many atoms I have. So looking, I've got CH4 and O2, so I have methane gas and oxygen gas. The only compound that contains carbon is methane, and based on the subscripts of this, there is only one atom of carbon per one molecule of methane, so that means I have shown here one atom of carbon. All right, let's look at hydrogen. So again, looking at both of my reactant molecules, I've got methane CH4 and oxygen O2. Oxygen does not contain any hydrogen, meaning the source of all the hydrogen thus far is our methane. And looking at the subscript in our chemical formula, we know that in one molecule of methane, we have 4 atoms of hydrogen. And then looking at my oxygen, this is the only source of oxygen, and in elemental oxygen, I have 2 atoms of oxygen. So this is what I've got going on my reactant side. Let's see if I am obeying the law of conservation of matter on my product side. So let's go hunting for some carbon atoms. So I've formed in my products carbon dioxide gas and water vapor. The only substance here that contains carbon is my carbon dioxide. So I now need to look to my subscript for carbon in carbon dioxide. There's only one. So far it looks like I'm good because I started with 1 atom of carbon and I wound up with 1 atom of carbon. Okay, coming up next, let's look at our, well, let's go in color code order. Let's do hydrogen. So looking at my products again, I've got carbon dioxide. This compound contains no hydrogen, meaning the source of all my hydrogen in my products is my water vapor. So I'm going to look at my water vapor here and use my subscripts to count a number of atoms. So here I see that for 1 molecule of H2O, I have 2 atoms of hydrogen. And then lastly, looking at our oxygen, in both my product compounds, carbon dioxide and water, I have oxygen, so I need to count in total. So from the carbon dioxide, that is 2 atoms of oxygen. And from the water, that is 1 atom of oxygen. So 2 plus 1 gives us 3 atoms of oxygen. So if I look at my product side and compare it to my reactant side, it looks like we do not obey the law of conservation of matter. We conserved our carbon, but where on earth did our 4 hydrogen atoms go in this particular chemical equation? And how is it that we have seemingly gained an atom of oxygen on the product side? So thus far, the answer is no. Now, I'm going to make a statement here. The reaction given above does indeed happen, meaning I can combust methane. So how is it that this reaction can happen if I'm not obeying my law of conservation of mass? And the answer to this question of how is we can balance a chemical reaction by adding whole number coefficients in front of our molecules where needed. So this is what's happening when we balance a chemical reaction. We're going to place coefficients or numbers out in front of our molecules. And let's think about what that's going to do for us. Well, maybe we'll get there in a moment. So let's look at our reaction again. So I've got CH4 gas reacting with O2 gas to form carbon dioxide and water vapor. Okay, so if I look at what I need based on this unbalanced reaction given here, which has my disobeying of my law of conservation of matter, I see that I'm fine when it comes to carbon atoms, but I am now deficient in hydrogen atoms in my products. Specifically, I have half as much as I need. So let's look at our products here. To start, I know that we need twice as much hydrogen on the product side. So this is kind of like our thought process or where we're starting. So how is it that I can get 2 hydrogen atoms on the product side without disobeying the law of conservation of matter? Because I can't just randomly write in hydrogen gas, because that's not what's made in this reaction. I've told you exactly what's made and what is used. So let's see here, let's go back to our definition. Balanced chemical reaction, we add whole number coefficients in front of the molecules where needed. So let's look on my product side. On the product side, the only molecule that contains hydrogen is water. And if I need 2 times the amount of hydrogen, then I'm going to put a coefficient out in front of the entire water molecule, meaning I'm going to double the number of H2O molecules. Okay. Now, before we move on, let's think about this. Since I am doubling the amount of H2O molecules, this means that I am also doubling my oxygen because H2O contains both hydrogen and oxygen. So if I double the amount of H2O, then I'm doubling both my hydrogen, where I now have 4, and my oxygen, where I have now 2. All right. So keeping tally, I can now strike this out. And let's think about this. I'm balanced in hydrogen. So I have 4 atoms of hydrogen. I've got my single atom of carbon. So let's look at our atoms of oxygen. So I have 2 oxygen atoms on the reactant side. And let's look at how much oxygen we have now on the product side. So I've got the 2 that are in my carbon dioxide, CO2, and now my doubled quantity of oxygen from my water. So there was 1 atom of oxygen in 1 molecule of water, meaning in 2 molecules of water, there's got to be 2 total atoms of oxygen. So that's 2 from the H2O plus 2. I have 4 oxygen atoms on the product side. So what does this mean I need? I need twice the amount of oxygen atoms on my reactant side. So looking at my reactant molecules, the only compound that contains oxygen is the oxygen gas, O2. And if I want to double the amount of oxygen atoms by balancing, I need to add a whole number coefficient in front of the molecule that contains oxygen. So I have 1, 2, 3, 4 oxygen atoms over here, 2 here on the reactant side. The only whole number coefficient that I can add that would double it is a 2. And let's go back and count again. So my carbon, 1 on the reactants and 1 on the products. My oxygen, I now have 4 on my reactants and 1, 2, 3, 4 on my products. And now then looking at hydrogen, I had 4 on my reactants and then 1, 2, 3, 4 on my products. So 4 and 4. Now we are balanced with these new coefficients that I'm going to rewrite down here. So we've got CH4 reacting with O2, specifically 2 O2s. To give us CO2 and then 2 H2Os, where these whole numbers out in front here, these are the coefficients that we get from balancing. And these coefficients now have provided a little bit of extra meaning or context to our chemical reaction. Because what we've done now is we have created a proportion or ratio of molecules in a chemical reaction. So if I were to restate this chemical reaction into language, I would say 1 molecule of methane gas, and let's use full language here, reacts with 2 molecules of oxygen gas to form, to yield, to create, that's what that arrow means, 1 molecule of carbon dioxide and 2 molecules of water vapor. So I've created, in effect, a recipe. That's what my balanced chemical reaction is. It tells me my molecular ratio needed for my reaction to proceed. So I can say that for 1 mole of CH4 reacted, that only happens if I've got 2 moles of O2 that are also reacted. I can also say something like for 1 mole of methane, I'm jumping ahead of myself, molecules, change all the molecules. So for 1 molecule of CH4 reacted, that requires 2 molecules of oxygen gas. I can also say that for 1 molecule of CH4 reacted, I generate 1 molecule of carbon dioxide. I can also say for every 2 molecules of oxygen reacted, I make 2 molecules of water, and so on and so forth. And if we were going to look at this visually, this is what this all translates to. I have 1 molecule of CH4 reacting with 2 molecules of O2. This is what's going to allow us to then have these bonds between carbon and hydrogen, and then our oxygen bonds be severed, so that we've rearranged it to form carbon with bonds to 2 oxygen and 2 water molecules with oxygen bonded to 2 hydrogens. Okay, I think we're going to have to restructure our plan for the day, because I've introduced balancing reactions for you, but I think what we're going to do now is we're going to change up what we're doing. Let's go ahead and practice balancing reactions together. And then after that is when we will get into our 5 main types of chemical reactions. So I will see you in our next video where we practice balancing some chemical reactions.